Hello students, today we'll discuss the electric field intensity at any point on the axial line of an electric dipole. Suppose we are having an electric dipole. Axial line means the line joining them, that is the positive charge and negative charge. Along that axis we have a line, and at a point we need to find out the electric field intensity. So now you can see here, suppose we are considering an electric dipole consisting of two equal and opposite charges. This is the center of the dipole, this is the point A and B. So we need to find out the electric field intensity at any point. Suppose this is P and this point is along the axis joining these two charges, that is the dipole axis. So this is known as the axial point. So to find out the electric field intensity at point P, as we already know earlier that electric field at any point due to a point charge is equal to 1 by 4 pi epsilon naught the source charge upon the distance between the reference point and the charge square. So that means E is equal to 1 by 4 pi is not Q upon R square. So we'll be using this formula in this derivation. So suppose what will be the, suppose the electric field intensity at point P due to the charge minus Q at A, that is EA. So you can find the direction of the electric field at any point can be determined by the direction towards which the unit positive charge is moving. So in this case, if we are putting a positive unit positive charge, then definitely it is going to be attracted towards A. So the electric field intensity at point P due to this charge minus Q will have a direction towards point A. So this is your electric field intensity at point P due to the charge minus Q in this direction. Similarly, the electric field intensity at point P due to charge plus Q, this will be along this direction. So if we are writing the magnitude of EA, so you can very well tell this will be equal to EA. So the distance between P and A. So if this is your A, this is your A, because the total distance between the dipole we have taken as 2A. So the distance from the center of the dipole to the reference point is considered as R. So in this case, the value of your PA will be equal to PA. So this is your OP plus OA. So this will be equal to your R plus A. Similarly, the length of this distance between the P and B, this will be equal to R minus A. So by considering these lengths, we can find out EA will be equal to 1 upon 4 pi epsilon naught the source charge upon distance square. So distance square will be PA square. So PA square is equal to your R plus A square. What will be the direction? Along PA. Similarly, we can find out your EB. So EB will be equal to 1 by 4 pi epsilon naught the charge upon distance square. So PB square. So PB square is equal to R minus A whole square. So if you compare these two things, you can find out here this will be along PX. So if you compare these two, we can say all the parameters are same except the denominator, that is R plus A. Here this is R minus A. So if denominator is less, then that term is the larger one. So we can tell here that EB is greater than EA, and as this electric field is between, they are acting along the same line, and one is right side, another one is left side. So their resultant will be, we can say these are the opposite vectors. So the resultant will be the larger vector minus the smaller vector. So this will be your EB minus EA. So the net electric field at point P will be equal to your EB minus EA. So if we subtract these two, we can find out your 1 upon 4 pi epsilon naught Q will take the LCM, that LCM of R plus A, R minus A. So this will be R square minus A square whole square. Now this will be equal to, this you can take, this will be R plus A EB. So EB minus, so EB will be, this is your 1. So this will be R plus A whole square minus, this is EA, that will be your r minus a whole square. So this total thing will come out as a plus b whole square minus a minus b whole square. We know the formula. This is for AB. So we can write here the resultant electric field EP will be equal to your 1 upon 4 pi epsilon naught Q. This will be your 4AB upon r square minus a square whole square. So here if we modify the things, that means if we can write here Q into 2a, again this is 2 into this is r divided by r square minus a square whole square. So this will come as 1 upon 4 pi epsilon naught. We know already Q into 2a is your dipole moment. So this is 2 pr upon r square minus a square whole square. Again, what will be the direction of this net electric field? So you can find out as these are the opposite vectors. So the direction will be along the larger vector. So larger vector is your EB. So the direction will be along PX. So we can conclude that the electric field intensity due to an electric dipole on its axial line will be along the direction of the electric dipole moment. So dipole moment is negative to positive, and also the net electric field is along the direction. So this is same. So the magnitude will be this one, and the direction will be along the dipole moment. So this is an important derivation in consideration with your CBSE board exams. Here we can also consider if this the dipole, that will be a short dipole. So we can find here if a is very less than r, then we can find that this a square or the higher powers of a can be neglected. So we can write your EP will be equal to 1 by 4 pi epsilon naught. This will be 2 pr upon, this is neglected, so r to the power 4. So r to the power 4 means this will cancel out. So we'll get 1 upon 4 pi epsilon naught 2p upon rq, and along this is px, or same as the electric dipole moment.